Yeah, we are in our matrix unit, and so far so good. It looked like last week most of you have got that turned in very quick. We'll look at this week's. I think this week we have actually less assignments than we had last week, so uh, kind of an easier week. Not that the matrices are overly tricky to start with, but let's go take a look at it. All right, in Buzz, going to our grade screen as usual. You should have turned in matrix dimensions, matrix elements, and representing linear systems with matrices. That's what was due last week. This week, we just have two items: matrix row operations and the matrix quiz, which is actually in Buzz. It is not at Khan Academy, so the matrix quiz is in Buzz. So basically, we're going to open up the week 26 folder and go through everything. This is week 26. We'll just look and see what the folder has. There's a lesson and a video that we need to look at before we get to the quiz, and we do have the one assignment. So let's switch back. I'm going to close the week 25 folder, open up week 26. There are two folders inside week 26. I'll go ahead and open both of those. So we have this lesson right here, followed by the assignment. Then this is actually a video and the quiz. So we'll take a look at the quiz before we go. We'll also go through this lesson right here to start off. So it takes you to this link. Remember, when you click on that link, it'll take you to the Khan Academy website. We can close this little half tab over here on the side. And, this way you can check to make sure you're logged in. If you're not logged in, it may have you like join with Google, and you may have to go through a couple of pages if you're not logged in. But if you're logged in, it remembers your score on anything. So if you forget to screenshot it, you can go back and recover that. But here we go. Matrix row operations. What can we do with matrices? So this summarizes the three elementary matrix row operations, things we can do with matrices. So I'm going to make this just a little bit bigger. Okay, so one thing we can do is we can take any two rows and swap them, switch any two rows. So I can take the first row and make it the second row, and take the second row and make it the first row. I could just trade places with the rows. And if we think about that, that makes sense, because if we have a systems of equations, it doesn't matter which equation you list first or which ones you list second. And so with a matrix, it shouldn't matter which row is first or which row is second. So we can do that. We can switch any two rows. We could multiply a row by a non-zero constant, which means we could take this first row, 2, 5, 3, and say I'm going to multiply everything times 3. So it's 3 times 2 and 3 times 5 and 3 times 3. So that would become 6, 15, and 9. And we wouldn't do anything to the second row. We could do that. Then we could say, get really fancy, say row 2 becomes the sum of rows 2 and 1. So the first row would not change, but the second row, we would say we're going to add these rows together. 2 plus 3, 5, 4 plus 5, 9, and 6 plus 3, 9. This row would change to be 5, 9, 9. And you're like, why would we ever do that? Well, if you think about how we solve systems of equations, you'll see that there are times this will work, and we'll look at more of that. But they can be used to solve systems of equation by doing these kind of operations. So let's look at switch any two rows. You may see this as the directions. You'll see R1 and R2 and this double arrow. That means take row 1 and row 2 and switch them. So on this matrix right here, we have 3 by 3 matrix, 4, 8, 3, 2, 4, 5, and 7, 1, 2. If we had this R1, R2 command, we would take the 4, 8, 3 and move it to the second row, take the 2, 4, 5, move it to the first row, and the third row would not change. It would not change at all, because it did not say to do anything to the third row. If it doesn't mention the third row, don't change the third row. But suddenly this matrix is the same numbers, just in a different order. We swap two rows. You may see it listed like this. Row 1, row 2, right there in between the matrices to show from here to here, here's what happened. We took row 1 and row 2 and we switched places. And the third row, again, not changed. So let's throw that out there. I'm going to open up the chat. Make sure you guys got this. If we did this, R2, double arrow, R3, what would the first row of this matrix look like after performing this operation? What numbers would we need to put there? All right. Yeah, you guys have got this. It says nothing about the first row, which means nothing changes for the first row. The first row is still 729 because this did not say to do anything. What about the second row? What's that going to be in our new matrix? Right, we're going to take that third row and make it the second row. So now the 1, 3, and 12 are going to move there. So our third row is going to be what? Yeah, it's going to be the 6, 4, 1 that was here. So we check that. Absolutely. Switching 2 rows, very simple. Just do exactly what it says. Look at the 2 rows and just trade places. Okay, now let's look at multiplying a row by a non-zero constant. You may see this command. It says 3R2 is the new R2. 3R2 is the new R2. So that means take this matrix, and the second row of the matrix is 2, 3, 0. We would multiply all of the elements times 3. 3 times 2, 3 times 3, 3 times 0. So this matrix becomes this one over here. So this is the new matrix right there. It has the 6, 9, 0 is the new second row because we multiply everything by 3. And we may see that again in between there as that 3R2 becomes the new R2. So you have the old matrix and the new matrix. 3 times the second row replaces the second row. And the other rows don't change. All right. So let's perform this operation. Perform this operation on the following matrix. What would our first row be after doing 2R1 becomes the new R1? Put those numbers in the chat. Fortunately, the math they're asking to do is like, first, second grade, right? We just have to multiply by 2, right? So it's 4, 12, 10, 2. Great job, guys. What happens to the second row? Nothing. It didn't say to do anything. So we just put the second row exactly like it was. Check. Perfect. 2 times the first row. Change the first row. Now, it could have said 2 times the first row becomes the new second row, in which case the first row wouldn't change. So pay attention. All right, now we're going to look at this row operation. R1 plus R2 is the new R2. Row 1 plus row 2 is the new row 2. So if we have this 2, 3, 4, 0, 8, 1 matrix, it's a 2 by 3, and we have this R1 plus R2 becomes the new R2. It says replace the second row with the sum of the first and second rows. So the first row doesn't change. It's still 2, 3, 4. But the second row is adding these together. Right? And then that is becoming the new second row. A new second row right there. So again, we may see it in between the matrices showing what happened to change this one into this one by adding the 2 together. So 0, 8, 1 becomes 2, 11, 5. But the first row didn't change. Okay, so let's see if we can do that. And there's 2 problems right here because it shows there's a second one right there. So let's look at the first one. Perform this operation.
Row 1 plus row 3 becomes the new row 3, which means what is our new first row? Let's do the first row first. What happens here? Is that confusing? Like, wait a minute, we're taking the first row and we're adding it to the third row. Yes, we are, but we're only replacing the third row. So the first row does not change. Even though we're adding to the third row, that only matters when we get to the third row, because that's the only thing it wants us to change. So we don't change the first row and we don't change the second row. I'll go ahead and put that in there. But what is the new third row of our matrix? First row plus third row. Change this color. It means we're taking this and adding it to this. -1 plus 7. So it's going to be a 6. Then if we add 6 and 2, take the first row and the third row, add them together. It's 8. It's -2 and 1. -1. Let's check that. Yeah. The only thing that matters is the third row is being replaced. It says replace the third row, which means nothing happens to the first and second row. But the third row changes by adding the first and third together to make the new third. All right. Good job. Oh, I said there's a second problem here. Well, let's look at this one. This one says row 2 plus row 3 is the new second row, which means the first row, -4, 12, 9, and the third row do not change. Only the second row changes. So what is the new second row? Yeah, a lot of times if you're working these, if you look at this, go ahead and put that first and third row in, because we don't want to forget those don't change. Only the second row changes. What is the new second row? Let's see. Row 2 plus row 3. Add those rows together. Those add together. All right. Everyone's got it figured out. Again, this is the easy math, right? We're just doing elementary school where we just add 2 rows together. 7 plus 1. We learned to do that a long time ago. 9 and 12, 8, 9, and 12. It's just 7 plus 1, 4 plus 5, 2 plus. We didn't even have a negative number to deal with. Check. Perfect. All right. Let's look at this one. This is a challenge problem. Challenge problem. Look what's happening to row 1. Row 1 plus 2 times row 3 is the new row 1. So I'm going to go ahead and put the second and third row while you're trying to figure out what the first row is, because it did not change the second and third row, only the first row. But you have to take row 1 plus 2 times row 3. All right. Somebody's going to mess this one up. I just feel it's just too complicated, isn't it, guys? Just too. No, I don't. I really don't think it's too complicated. I think you guys can nail this. I don't think you've missed a single one. So row 1 is -5, first element. Row 3 is 8, and we have to double that. It says 2 times row 3. So 2 times 8 is 16. And if we add a -5 to 16, that should be 11. All right. Everybody saying 11? The one that's figured it out. We've got 8 again on row 3. So we have to double that to be 16, and we add it to the first row. So 16 plus 7. Oh, you guys did put the wrong number there. I think it's a 23. You guys are saying 22. I see a lot of 22s there. 16 plus 7. Now we're going to double this for the third element. That'd be negative 12. Plus 3 would be negative 9. Yeah, I think some folks were playing follow the leader and didn't calculate themselves. Let's see. Yes, it's 23, 16 plus 7. 11, 23, negative 9. So if we look at systems of equations and how it's related to these matrix row operations, if we had this system right here, right, we got 1x plus 3y equals 5, 2x plus 5y equals 6, and we turned it into a matrix, right, which we can do. If we switched any two rows, well, that's just because we could take a system of equations and we could list them in the other order, which means our matrix would just turn around and be the other order. That's equivalent. It's exactly the same. The order of operations does not matter when you have the other equation listed first. So we can legally interchange any two rows in a matrix, and it does not change it. It's still equivalent. It's equal to what it was before. If we're multiplying by a non-zero constant. Now, remember, when we solve a systems of equations right here, sometimes we want to add them together and eliminate something. So like to do this with the x column, we have a 1x and a 2x. So we might multiply the first row by negative 2 so that we have negative 2x and positive 2x. So when we add these rows together, the x's are eliminated, right? Elimination was one of the methods to solve systems of equations. So I'd multiply the first row by negative 2 all the way across. So I'd get the negative 2, negative 6, negative 10. Well, that's why we can do that with a matrix. We can multiply the first row by negative 2. Because when we were solving systems of equation, that is one of the methods we did. So we could add them together and the x would go away. So that's how that's related to doing this with a matrix. Adding one row to another. So like in this system, when we add those together, because we turned that into a negative 2x, we end up with negative y equals negative 4, right? So if we had a matrix and we wanted to add two rows together, the second row would now be y equals negative 4 because the x is a 0. You see that over there too, the 0x. So that helped us simplify this matrix. Why do we keep one of the original equations? When we add the equations, we obtain negative y equals negative 4, or y equals 4, but the other equations have not disappeared. We use the other equation to solve for x. We'll use that equation next, and we'll get that to be an x equals. All right. Oh, concluding challenge problem. Let's take a look at this problem. A sequence of row operations is performed on this matrix. Okay, we're starting with this matrix. The table below describes the result of each step. And we got to figure out what were the steps that were used. So I need to make this a lot smaller. Can we see all of it there and now? Okay. So here is our original matrix right there. And it went from this to this. How did that happen? Which one of these four things caused the original matrix to turn into this? Did we take the first row, subtract the second row, and make that the new first row? Did we take the first row and multiply it by 1/2? That's the new first row. Did we add the two rows together and make that the new second row, or did we take -1 times the second row and make that the new second row? Well, let's look at this. Let's just, in the chat, this would be option 1, option 2, option 3, option 4. So just tell me 1, 2, 3, or 4. What did we do to get this? Starting with the top one, right? We started with that one. Well, looking at that, the first row did not change, right? Oh, that didn't mean that. First row didn't change. It's still 2, 2, 10. So it can't be this one, and it can't be this one because both of those changed the first row. It has to be number 3 or number 4. So what did we do to change -2, -3, 3 to 0, -1, 13? I'll give you time to think through that. One of those two things. One of those two things would cause this row to turn into this row. Maybe I need to ask this a different way since we're kind of confused on this. Let's assume, Greenland says it's the third one. Let's assume we do the third one. What would the new row 2 be? What would row 2 be if we did that? We add those together. Right? We just add those together. 2 plus -2. That'd be 0. 2 plus -3. -1. 10 plus 3. 13. That means I can take this one and move it up here because that's what happened. That's what happened. We took the first row and the second row and we add them together to create the new second row. Okay, so now this is 1, 2, 3, 4. We've rearranged. How did we go from here to here? Which operation did we do? 1, 2, 3, or 4? Well, obviously we didn't do 1. 1's already taken. 1. So this is 2, 3, or 4. Braden likes that 3 again. Cooper likes 3. So let's see. The row 1 was 2, 2, 10. Now it's 1, 1, 5. Went from 2, 2, 10 to 1. The second row didn't change. But yeah, 2, 2, 10 to 1, 1, 5. It must have multiplied everything by 1/2 because it's half as big as it was. Great. All right, now how did we go from that to this? It looks like the first row stayed the same, right? 1, 1, 5, 1, 1, 5. So the second row changed. What happened to the second row? It was 0, -1, 13. Now it's 0, +1, -13. Oh, it looks like we just multiplied it by -1. Which means the last one must be we subtracted row 1 minus row 2 and made that the new row 1. So row 1 minus row 2. 0, 1 minus 0 is 1. 1 minus 1 is 0. Yes, if we subtracted that. 5 minus 13 is, 5 minus a -13. That means we add, right? -13. So it would be 18. Check. Good job. So the original equations, now look how this turns out. What's our final? This is, if we put this back into an equation, this is x equals 18. There's no y. Y is gone. This is x equals 18. There's no x. This is y equals -13. We have solved the systems of equation. We started with 2x plus 2y equals 10 and -2x minus 13 equals 3. And we used matrices to get it to this. X equals 18, y equals 30. We solved it. All right. Let's go back here. That is this lesson. Let's do the assignment that goes with it. Click on matrix row operations. I'll take you to Khan Academy. We can close a little side tab. Ready to practice. Yes, let's go. Get bigger. 2R2 is the new R2. New R2. So that means I'm going to go ahead and put row 1 in there because nothing changed. And I'm going to put row 3 on there because nothing changed. The only thing that changed is row 2. And row 2, I just have to double it. Take the old row 2, multiply it by 2, make it the new R2. Good job, Truman. 14, 8. Oops. 0, 0. 2 times 0 is still 0, folks. Let's turn that in. Great work. All right, next question. Row 2 switches places. Switches places with row 3. So row 1 did not change. We're going to go ahead and put that in since we know it's exactly the same. It didn't say anything to do with row 1. But all we do is we take row 3 and we move it and put it where row 2 is. So we're just going to take these two and trade places. 1, 4, negative 6, 2. 3, negative 2, 2, 2. Oops. All right, so this row moved down there. That row moved up here. Okay, check. Next question. Ooh, this one's tricky. The new row 1 is going to be row 1 plus 4 times the third row. So second and third row don't change. But what's the new row 1? Row 1 plus 4 times row 3. So row 1 is negative 3. Row 3 is 2. 2 times 4 is 8. So we're going to add 8 plus negative 3. Put it right there. That would be 5. 4 times row 3. 4 times 8. And then add that to negative 4. 4 times 8 is 32 plus negative 4. Good job. Got some folks getting the answers there. All right. 4 times 6 plus 3. 27. 4 times 5 plus 0. Well, that was a little easier. All right, one more. Negative 6 times row 3 is the new row 3. So row 1 and row 2 don't change. So let's go ahead and put that in there. Okay, nothing different for the first two. But the third row is just multiplied by negative 6. Just take every number times negative 6. So 2 times negative 6. Negative 3 times a negative. That's a negative times a negative, so we're positive this time. 1 times negative 6. And negative 7 times negative 6. Perfect. All right. So let's take our screenshot now. Show our summary. Screenshot. Go back. Okay, there's my screenshot. Go back to Buzz. Scroll to the bottom of that same page. Paste our screenshot. 4 out of 4. Submit. Don't forget to submit. It'll say you haven't turned it in. And you'll see that when you go to the grade screen. It'll say you haven't submitted anything. Okay, so we have done this first folder. Let's close that. The second folder just has one thing, and then our quiz. So let's look at this. This should be a video. It's going to show us solving linear systems. This goes through actually solving one now. Let's watch this video. I think it's about 7 minutes, and that'll be the end of that. And then all the left is the quiz. So here we go.
Figure it never hurts getting as much practice as possible solving systems of linear equations. So let's solve this one. And what I'm going to do is I'm going to solve it using an augmented matrix, and I'm going to put it in reduced row echelon form. So what's the augmented matrix for this system of equations? 3 unknowns with 3 equations. So it'll be, I'll just have to do the coefficients. So the coefficients of the x terms are just 1, 1, 1. Coefficients of the y terms are 1, 2, and 3. Coefficients of the z terms are 1, 3, and 4. 1, 3, and 4. And let me show that it's augmented. And then they equal 3, 0, 3, 0, and minus 2. Now I want to get this augmented matrix into reduced row echelon form. So the first thing, I have a 1 leading 1 here. That's a pivot entry. Let me make everything else in that column equal to a 0. So I'm not going to change my first row. So it'll just be a 1, a 1, a 1, and then my dividing line, and then I have a 3. Now, to zero this out, let me just replace the second row with the first row minus the second row. So 1 minus 1 is 0. 1 minus 2 is 1 minus 2. Actually, a better thing to do, because I eventually want this to be a 1 anyway. Let me replace this row with the second row minus the first row, instead of the first row minus the second row. I can do it either way. So the second row minus the first row. So 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. And then 0 minus 3 is minus 3. Now, I want to also zero this out. So let me replace this guy with this equation minus that equation. So 1 minus 1 is 0. 3 minus 1 is 2. 4 minus 1 is 3. Minus 2 minus 3 is minus 5. Fair enough. So I got my pivot entry here. I have another pivot entry here. It's to the right of this one, which is what I want for reduced row echelon form. Now I need to target this entry and that entry, and I need to zero them out. So let's do it. So we get, I'm going to keep my second row the same. My second row is 0, 1, 2, and then I have a minus 3 in the augmented part of it. And to zero this guy out, what I can do is I can replace the first row with the first row minus the second row. So I get 1 minus 0 is 1. 1 minus 1, there's a bird outside. Let me close my window. So where was I? I'm replacing the first row with the first row minus the second row. So 1 minus 0 is 1. 1 minus 1 is 0. No, I don't want to make it. 1 minus 1 is 0. 1 minus 2 is minus 1. And then 3 minus minus 3. So that's equal to 3 plus 3. So that's equal to 6. Right? 1 minus 0 is 1. 1 minus 1 is 0, negative 1. And then 3 minus negative 3, that's 6. I always want to make sure I don't make a careless mistake. Now let me get rid of this entry right here. Let me zero that out. So let me replace the third row with the third row minus 2 times the second row. So we have 0 minus, 2 times 0. That's just going to be 0. 2 minus 2 times 1. That's 2 minus 2. That's 0. 3 minus 2 times 2. That's 3 minus 4, or minus 1. And then finally, minus 5 minus 2 times minus 3. Let me write that down. Minus 5 minus 2 times minus 3. That's minus 5 minus minus 6. That's minus 5 plus 6 is equal to 1. I really wanted to make sure I didn't make a careless mistake there. So that is equal to 1. So I'm almost done, but I'm still not in reduced row echelon form. This has to be a positive 1 in order to get there. It can't be anything other than a 1. That's just a style of reduced row echelon form. And then these guys up here have to be zeroed out. Well, the easy thing to do, let me just multiply this equation by minus 1. So then this becomes a plus 1, and then that becomes a minus 1. And then I just need to zero out these two guys up here. So let's do it. So my equation, I'm going to keep my third row the same. My third row is now 0, 0, 1, minus 1. 0, 0, 1, minus 1. And now I want to zero this guy out. So what I can do is I could set my first row equal to my first row plus my last row. Because if these two add up, they're going to be equal to 0. So what do I get? 1 plus 0 is 1. 0 plus 0 is 0. Minus 1 plus 1 is 0. 6 plus minus 1 is 5. Now I want to zero this row out. And to zero this row out, what I can do is I'll replace it with the second row minus 2 times the first row. Right? So 0 minus 2 times 0 is just 0. 1 minus 2 times 0 is just 1. 2 minus 2 times 1 is 0. Minus 3 minus 2 times negative 1. Let me write that down. Minus 3 minus 2 times minus 1. Don't want to make a careless mistake. So what is that equal to? This is equal to minus 3 minus minus 2, or minus 3 plus 2, which is equal to minus 1. So that's equal to minus 1. And now I have my augmented matrix in reduced row echelon form. Reduced row echelon form. My pivot entries are the only entries in their columns. Each pivot entry in each successive row is to the right of the pivot entry before it. And actually, I have no free variables. Every column has a pivot entry. So let's go back from the augmented matrix world and kind of put back our variables there. So what do we get? We get x plus 0y plus 0z is equal to 5. That's that row right there. We get 0x plus 1y plus 1y plus 0z is equal to minus 1. That's that row right there. And then finally, we have 0x plus 0y plus 1z is equal to minus 1. That's that row right there. And just like that, we've actually solved our system of 3 equations with 3 unknowns. That's the solution right there. I just wrote it in this way just so you see it corresponding, but obviously I could have written them closer to their equal sign. So hopefully you found that vaguely useful.
All right, so what we saw there was he was solving the systems equation using these operations that we've looked at, swapping rows or multiplying rows by numbers or adding rows together. I'm going to show you something real quick on that before we look at our quiz. So this is what he started with right here, right? This one, 111, 123, 134 with these. And the goal was to get it to this. This is called reduced row echelon, which means we've only got one variable left in each row. This is the x with 0 y's and 0 z's. There's 0 x's and only 1 y. So there's only an x, there's only a y, there's only a z. That's what reduced row echelon form is. But when he took this, starting with this, and he did all those different operations, he tries to get that at 1, and then the next thing he does is try to get zeros in that same row, in that same column, I'm sorry. Then he worked on the next one to get this to be a 1, and then get zeros in that. And just did whatever operation needed to be done to get it to this finalized form. So that's what reduced row echelon is just making that x equals 5, y equals -1, and z equals -1. So don't get too confused about that. We're not solving any this week. We're not looking at how to do. We just want to understand how those operations work so we could solve that. I do want to show you one other thing, because you'll need to know this for the quiz. One thing that we haven't seen a lesson on anything is how do we add two matrices together? Adding, right? So if I want to add these two matrices, now the most important thing is they have to be the same size. These are 2 by 2s. These are both 2 by 2s. To add them together is pretty simple. We take the first row, first element, and add it to the first row, first element. And 2 plus 1 is 3. To get the second one, -1 and 2. This is the first row, second element. That is 1, because -1 plus 2 is that. 0 is the first column and the second row. And so is 3. Those are in the same position. So we can add those together. And let's see, where's my other color? I had another color. This works. And then we have 5 and 4. And they're both second row, second column. So that's as simple as that is. Just make sure you have the same thing in the same position. Now, you're going to see a question like this on the quiz. You're going to see something like this, and it's going to ask you, what is X and Y? And it's got all this already filled in. So all you have to do is figure out where is X. Well, here's X on this one. There's X. So if X plus 2 equals 5, what is X? Right? That's what this is. X plus 2 equals 5. That's what that is. So obviously X is 3. That's pretty simple. Y is over here. We're looking for Y, which means this is 4 plus -4. 4 plus -4. So don't make that hard. That is really simply just adding numbers together. And so in the quiz, you'll see that where it's got an X and a Y in the matrices. And you just have to figure out what would the numbers be for X and for Y. All right, so let's take a look at the quiz. I'm going to close that. Go back here. The quiz is in Buzz. Hit start. Now, you can ignore all this up at the top. I mean, that's just something that Buzz has in order to be able to produce a matrix. So this is reviewing everything we've learned on matrices. What are the dimensions? How many rows and columns? What is the 3, 2 element in this matrix? All right, it's a big matrix, but you can figure out the 3, 2. How would you write this systems of equation as a matrix? And there are 4 choices. 4 choices. So you have to look and see. Remember, like this one is missing a T. This one's missing a Y. This one's missing an X. So there's zeros in those matrices. So you got to make sure the zeros are in the right place. Question 4. Do this row operation is what we were just looking at on this matrix. And which one of these 4 would that be? And then here's the last one where I said you've got an X and a Y that you have to figure out what numbers they are if we are adding these 2 matrices together. So that's it, guys. You've got 1 assignment on Khan Academy, 1 quiz in Buzz, and that's it for this week. So get that done. If you haven't got the last matrices done, they're quick, 4 questions each. Make that screenshot, turn it in Buzz, and we'll see you next time. Have a great week.